I wanted to make a video that complemented our discussion of naming chemical compounds that we've been having in class. You'll be given a formula that you'll want to then try to name. Before you name it, you'll need to identify whether it's ionic, covalent, or an acid. This is important because the rules vary between these three categories. So the first question you'll ask yourself is, what type of elements are present in the formula? If it's a metal and nonmetals, then you have something that is ionic. For example, something that is ionic could be something like sodium chloride, which would have a metal and a nonmetal. Remember, metals are on the left-hand side of the periodic table and nonmetals are on the right. A covalent compound would contain all nonmetals or some metalloids, and it would be something maybe like CO2. So that has all nonmetals. And then acids are going to have hydrogen in the front of the formula, and then they'll be accompanied by other nonmetals. And sometimes it's just hydrogen with one other nonmetal, or it could be hydrogen with a nonmetal and some oxygens. And we'll talk about the difference when we get to the acid section. So your first question will be, what type of elements are there? So I'm going to go through I'll do ionic, then covalent, and then the acids. So let's start with ionic. So we have a formula, we'll say it's NaCl just to start with, and we've identified it as ionic. So let's say we have NaCl, and we've identified it as ionic. Ionic compounds, the metal will always be first. It forms the cation or the positive ion, and followed by the nonmetal, which is the anion. To name the metal, you just name it as the same as the element. So for our example up there, Na is sodium, so this would be called sodium. And then the nonmetal, you'll take the stem or the first part of the element name and change the ending to IDE. So instead of chlorine, we would have chloride. So NaCl, we're all very familiar with it, and we can see sodium chloride. And that's the basic way of naming ionic compounds. But there are a few things that may come into play. So let's take a look. So when you have an ionic compound, one of the things you'll need to ask yourself is, the metal or the first element, can it form more than one cation? In the example sodium chloride I gave you, sodium can't. Most of the main group or representative elements will only form one ion, as we predict by the octet rule. Remember, by the location on their periodic table. So for example, in our first one where we had sodium, so that's the ion in sodium chloride, we would just call it sodium. Or we could have had magnesium, which is an alkaline earth metal in group 2A, and we would call that just magnesium. And we would actually call it a sodium ion and a magnesium ion. I don't have very much space right here. Now, the other possibility, many of the transition elements, as well as some of the post-transition elements like lead and tin, they can form more than one cation. They have more orbitals available, and so there's a variety of ways that they can lose their electrons. Now, if that happens, we know that charges will affect the formulas. So we have to then tell the person who's looking at the name what charges of the element we had. So like, for example, iron can form a 2+ and a 3+. Well, that's important because if it's a 2+ or a 3+, the formula will be different. So what we do to tell them in the name is we say the name of the metal, iron, and we follow it by a Roman numeral. Or that would be iron 2, and then iron 3 would just be called iron, and then we follow it by a Roman numeral 3. So the Roman numeral is just telling us the charge. Now the other question we have to ask ourselves in ionic, so it's not just as simple as metal and nonmetal. The other question is, well, is there a polyatomic ion? Polyatomic ions, once you memorize some of them, are actually not so hard, But initially it's really hard because polyatomic ions will have more than one nonmetal, and you can't really tell the name by the formulas until you've memorized things a little bit. But once you recognize them, you just call the polyatomic ions by their names. So for example, SO4 2- is a sulfate ion, and NO3- is another example. That's a nitrate ion. So if there's a polyatomic ion, you'll just name it by whatever the name is for that polyatomic ion. So let's do a few examples, and I'll try to do one example of each type, and we've done these in class 2, so this isn't supposed to be completely inclusive, but let's just do, or exhaustive, all the examples I can think of, but let's just do some examples. So here would be one example. And so the thought process, I see that there's a metal and a nonmetal, so I know it's ionic. Then I look at my metal, it's calcium. Calcium is in group 2A. It only forms a 2+ charge. Remember, most of the main group elements will only form one charge. And so I just name it as the same as the element name, followed by, remember the nonmetal, we take the stem and change the ending to IDE. So CaCl2 would be named calcium chloride. Now what if I have the example like this? So I know that this is a metal and a nonmetal. So remember, the first page I have to say what type of elements. So I thought, okay, it's a metal and a nonmetal, so I know it's ionic. Then I look and I think copper. Copper's a transition element, and copper can have two charges, a +1 and a +2. So I know it's going to be a copper. And because it can have more than one charge, I have to figure out what the Roman numeral will be to tell the charge. And then I know the second element, I could already write it, is going to be the nonmetal name, and you take the first part of the element and then change the ending to IDE. So it's oxide instead of oxygen. Now back to that copper. I'm going to change my pen color here so we can think about it. Anytime you have a 1-to-1 relationship, one copper, one oxygen, we know that the number on their charge is the same. So to figure out what copper is, I'm going to look at the oxygen. Oxygen is in group 6A, so I know it is a 2-. Now since it's a 1-to-1 relationship, then I would have to know that the copper is a 2+ because the number here and then the number of the 2 has to equal the 2 because it's 1-to-1 and they cancel. So copper can have a +1 and a +2, but in this example, when copper's with oxygen in this relationship, copper is a 2 right there. Now notice it's not because I have 2 coppers, it's because copper has a charge of 2. Now finally, you could have a polyatomic ion. So let's see. So I look at this guy here. Remember, the first question would be, is it ionic, covalent, or an acid? I see it has a metal, potassium, and then a whole bunch of nonmetals. Once you memorize it, you would recognize this group right here as phosphate. But initially, if you don't recognize it, get a table of the polyatomic ions. And if you have a metal that is followed by a group of nonmetals, then you know you're dealing with a polyatomic ion. So we're going to name it the metal potassium. I ask myself, can this form more than one charge? And it can't. Potassium's in group 1A. So I'm just going to name it the same. No Roman numerals because it only forms one charge. So that's the same as the element. And then when it's a polyatomic ion, we follow it by the name of the polyatomic ion. So there's an example of each, and I just kind of hope that talking through how you have to think about the words helps you get that dialogue going when you're doing your work. So now let's go to the second type. So this is covalent. So remember on the first page I said you had to say ionic. You had to ask yourself, that's metals and nonmetals. And then covalent, this is when you have two nonmetals. And we're naming something called binary covalent, which means it's just going to have two different nonmetals. There can be, in covalent compounds, there's other things that we could name, but this is what we're doing. So in covalent compounds, it's going to start out kind of like ionic. Remember, though, I just want to remind us, since we don't have the first page, these are going to be two nonmetals, or a metalloid could show up here. Okay, and the first nonmetal is going to be the same as the element name, and the second nonmetal is going to be just like before, the stem of the second nonmetal, but we're going to change the ending to IDE. Now here is the big difference in covalent compounds. In ionic compounds, the ratio is determined by the charges, so we can always figure out how many we have of each because of the charges. But in the covalent compounds, there's no charges. So the only way we're going to figure out how to know how many of each is by writing prefixes in the name. So prefixes like mono, di, tri, tetra are going to tell us how many we have of each. One thing to keep in mind is mono is not used on the first element. So let's do some examples. Let me write a couple of them here. I had CO2 on the first page. We'll do that one. Let me think of another one. Okay, so what you're going to do is name it by using the prefixes. So the first element, here's the number 2, so I would put di. And then the first element is nitrogen, so I would say dinitrogen. The second element, I have 5, so I would say pent. Now, this is the funny thing. Oxygen is going to be oxide, and a lot of times when you have the A and the O together, they'll drop the A, so they'll just say pentoxide instead of pentaoxide. On the exam, if you wrote pentaoxide, I would just cross out the A, but I wouldn't take it off. Some of that comes with practice. Okay, so the second one, I see there's only one carbon, so I'm not going to use mono on that one. I'll just put carbon. There's 2 oxygens, so I'd say di for 2 and then oxide. On the third one, here's phosphorus. There's only one, so I'm going to write phosphorus. Then there's 3 of these, so I would say tri, and then that is chloride. In a way, I like covalent compound naming because when I see the names, I don't have to think about charges. The names tell me exactly how many I have of each element, and so it seems a little bit easier. Now finally, I'd like to talk about acids. And I know this is a brief overview. Remember, this is supposed to complement the time that we've spent in class. But acids, what you're going to look for is hydrogen at the first, as the first element. So we're going to, think to yourself, hydrogen in front. So just to review again, the question you'll ask yourself very first when you see the formula is what elements are there? If there's a metal and a nonmetal, you'll follow ionic rules. If there's 2 nonmetals, you'll follow covalent rules. Remember those prefixes. And if there's a hydrogen in the front followed by nonmetals, then you have an acid. Now really acids occur when you dissolve these substances in water. For the purpose of this chapter, when you have hydrogen in front, I want you to name it as an acid because I want you to be good at practicing naming acids. So the first example would be if you had hydrogen with just one other nonmetal. So if we do that, the pattern is going to be hydro, the stem of the nonmetal, ic acid. So let me show you some examples. So HCl, so I see hydrogen in the front, it's followed by one other nonmetal, so it's hydro. The stem of chlorine is chlor. I'm going to change the ending to ic, so it's hydrochloric acid. Okay, so let's say H2S. Hydrogen is in the front, So it's an acid. It just has sulfur, so it's hydro. Sulfur's a little bit weird of a guy. It's sulfur. They use the whole thing for sulfur, probably because it's so short. Sulfuric acid. Let's try one more. HF. This would be hydro. And then fluorine would be fluoric. And then acid. So you see, it's when you have hydrogen with one other nonmetal, it's hydro for the hydrogen, the stem of the nonmetal, and the ending changed to ic. Hydro, sulfuric acid, hydrofluoric acid. So that's when you have hydrogen and only one other nonmetal. A second case would be if you have hydrogen first and then a polyatomic ion. So you would have a polyatomic ion is going to have, they're called oxyacids. They'll have one other nonmetal and then some oxygens. So it will be hydrogen, a nonmetal, and some oxygens. Now these are naming these are based on the polyatomic ions. So here's the basic rules, and then we'll do a couple examples. So if the polyatomic ion, if it ends, oops, sorry, I just made a mark. If the polyatomic ion ends in 8 right here, then you're going to change that to ic. So let me give you an example below. So if I had H2SO4, this right here is sulfate. Ooh, I'm going to run out of space, sorry. Sulfate. So see, there's the 8. So you change it to ic. So they call this sulfuric, and then you put the word acid. So notice that there's no hydro in these. There's no hydro. It's all based on the polyatomic ion. When you write the word acid, they know it's with hydrogen. Now, a question you may say is, well, why does that have 2 hydrogens? Remember, it has to do with the charge. So sulfate is SO4 2 negative, so it takes 2 hydrogens. Now, what about if we have an ite ending? That's going to change to us. So let's say I have, HNO2, oh, I don't want a minus, sorry, HNO2. So NO2 is nitrite. So see that ite right there? So ite is going to change to OUS, us. So it is nitrous, there's the OUS, acid. Again, there's no hydro in these because these are all based on the polyatomic ion. Now, why does the nitrous acid only have 1 hydrogen? Because NO2 has a -1. So hydrogen's a +1, so it only takes 1 hydrogen. So let's do a couple more examples for these. And let me think of them. Okay, so to do this, this is what we would see. Hydrogen first, followed by another nonmetal and oxygens, a polyatomic ion. So you identify the polyatomic ion. This guy is nitrate. 8 goes to ic, so it's nitric acid. Then the second one, and nitrate is NO3 negative. That's why there's only 1 hydrogen. Okay, CO3 is carbonate. It's CO3 2 minus. That's why there's 2 hydrogens. Okay, here's 8 goes to ic. This is carbonic acid. No hydros on these. Hydros only when it's hydrogen and 1 other nonmetal. This guy right here is ClO2 negative. It's chlorite. So ite goes to us. It's weird. And it's chlorous acid. And again, there's only one hydrogen because chlorite is a -1. Now, naming can be challenging. There's all sorts of rules, but like I always say, practicing will make you more confident and will make you better at naming. So remember, the first thing you're going to do is identify something as ionic, covalent, or an acid based on the elements involved. Once you get into that, then you'll have to look at the various rules or subtle changes in each thing to decide its naming. Now keep practicing and you will be perfect.